There's a star out there so massive, so ridiculously enormous, that if you replaced our sun with it, Mercury, Venus, Earth, Mars, heck, even the Kuiper Belt, would be swallowed without a second thought. Its sheer size is almost comical, like the universe decided to show off and said, "Hold my light years." Humor sneaks in because imagining Earth as a cosmic cherry on the rim of this stellar sundae is terrifying, but also absurd in a way that makes you laugh nervously. Astronomers have been tracking it, measuring it, and double-checking that they didn't accidentally misplace a decimal point. And every time they calculate its energy output, the numbers are so enormous that even black holes pause to blink. This star isn't just large, it's powerful in ways that make our sun look like a polite night light. It burns through fuel at a rate that would make a nuclear power plant look like a kid playing with sparklers. Humor creeps in because its lifespan is so short, astronomically speaking, that it's essentially a live, fast, die-young celebrity of the cosmos. In just a few million years, a blink on the cosmic clock, it will either collapse into a black hole or explode as a hypernova, releasing more energy than our sun will produce over its entire 10 billion-year lifetime. And when that happens, any nearby planets, if they somehow survive the sheer size, will be obliterated without warning. Finding this behemoth was no small task. Astronomers combed through light curves, spectra, and distances, looking for anomalies in the constellation where it resides. Humor sneaks in because it's almost like searching a massive cosmic haystack and realizing the needle is emitting more light than an entire city. Its discovery rewrites what we thought was possible for stellar mass and energy. Before this, the biggest known stars already made heads spin, but this one takes it to an entirely new level, a cosmic flex in stellar proportions. The energy it emits is so intense, it reshapes the space around it. Stellar winds from such a giant are mind-blowing. They push out gases, sculpt nebulae, and trigger the birth of new stars in its neighborhood, like a hyperactive cosmic parent. Humor creeps in because it's as if this star is a drama queen, flinging material around with zero regard for the consequences, while other stars quietly mind their own business. Its radiation is lethal at unimaginable distances, reminding us that size isn't just about presence. It's about influence, domination, and absolute chaos. Despite its terrifying power, the star also offers a rare glimpse into stellar evolution at the extreme. Understanding how it forms, lives, and dies teaches astronomers about the physics of nuclear fusion, gravity, and the limits of matter. Humor sneaks in because it's almost as if the universe handed scientists a problem that says, "Here, calculate the impossible. And by the way, it's probably going to explode." Observing its brightness fluctuations, its chemical composition, and its interactions with nearby stars is like reading the biography of a superstar whose every action affects billions of others across light years. But it's not just raw size and energy that make this star terrifying, it's the unpredictability. With stars this massive, small changes in core fusion processes can accelerate their demise, trigger massive eruptions, or even fragment the star. Humor creeps in because imagining a star having mood swings that could destroy entire systems feels both ridiculous and completely plausible. In cosmic terms, it's a ticking time bomb of unfathomable proportions. And then there's the afterlife. When this star reaches the end of its short, fiery life, it won't just go quietly. Its death throes could generate a hypernova explosion hundreds of times brighter than a regular supernova, potentially visible across the galaxy. Humor sneaks in because while humans complain about traffic or deadlines, this star's deadline involves annihilating matter across unimaginable distances, which makes our petty problems feel adorably trivial. It might even collapse into a black hole, a gravity well so dense it would swallow light itself, a reminder that extreme scale comes with extreme consequences. Ultimately, the biggest star ever found is a mix of beauty, terror, and sheer absurdity. Humor creeps in because while we marvel at it through telescopes, it remains oblivious to our fascination, burning fiercely, sculpting the cosmos, and existing in a way that is completely beyond human scale. It challenges our understanding of physics, pushes the boundaries of what we consider possible, and reminds us, in a way both terrifying and hilarious, that the universe is bigger, stranger, and more dramatic than we ever imagined. Measuring a star this colossal is a challenge that would make even the most seasoned astronomer break into a nervous laugh. It isn't like holding a ruler up to the sky. Instead, scientists rely on light, spectra, and models of stellar behavior, piecing together clues from millions of light years away. Humor sneaks in because it's essentially cosmic detective work, except the crime scene is a glowing ball of gas the size of several billion suns, and the suspect might explode at any moment. Every observation, every calculation, has to account for variables that are almost absurdly extreme. Fusion rates that make our sun look like a toddler with a flashlight, gravity that could crush mountains in seconds, and radiation that would turn anything nearby into plasma faster than you can blink. Its mass alone is a staggering figure, tens to possibly hundreds of times the mass of the sun. Humor creeps in, because thinking about that number is almost comical. We're accustomed to stars being points of light in the night sky, yet this one could fit countless suns inside it, and still have room for a few solar systems to play tag. Astronomers have had to refine their models of how such stars form, questioning whether the traditional theories of gas clouds collapsing under gravity even hold at these extremes. Observing its brightness and calculating its energy output has been a constant exercise in humility and disbelief. Then there's the star's surface temperature and luminosity. This behemoth shines so intensely that any planet within 1,000 astronomical units would be incinerated instantly. Humor sneaks in because while we fret over whether we left the stove on, this star is busy radiating. More energy in 1 second than humans have consumed in billions of years. Its light is so bright it can outshine entire clusters of stars, making it both a cosmic lighthouse and a terrifying warning sign of what raw, unrestrained energy looks like. The stellar winds it produces are another story. Most stars have gentle winds, a few that stir up the local neighborhood. But this giant? Its stellar winds are violent, blasting material outward at millions of kilometers per hour. Humor creeps in because it's as if this star is a cosmic toddler flinging spaghetti everywhere, but instead of noodles, it's high-energy particles that could strip the atmosphere from any nearby planet. These winds sculpt the surrounding space, trigger star formation in some regions, and prevent it in others, asserting dominance over its galactic neighborhood with zero concern for diplomacy. Astronomers have also been puzzled by its internal structure. Stars this massive are almost entirely convective, with hot plasma moving chaotically through their cores. Humor sneaks in because imagining a ball of gas the size of hundreds of millions of kilometers, churning like a cosmic lava lamp, is as ridiculous as it is fascinating. These turbulent interiors drive fusion rates, dictate lifespan, and ultimately determine how and when this stellar titan will die. Even small fluctuations could trigger massive eruptions or accelerate its collapse, making it unpredictable in ways that both excite and terrify scientists. Its eventual death is a story no less dramatic than its life. When a star this big runs out of fuel, it doesn't simply fade away, it explodes. A hypernova or even a parent stability supernova could occur, releasing energy so immense that nearby star systems would be obliterated. Humor creeps in because while humans consider a fireworks display thrilling, this is more like the universe's version of setting off a bomb that could light up a billion galaxies. The resulting black hole, if it forms, could become one of the most massive in the galaxy, a gravitational sinkhole that warps space and time around it. Despite its terror, this star is also an invaluable laboratory. Observing it allows astronomers to test theories of nuclear fusion, stellar evolution, and the limits of matter under extreme conditions. Humor sneaks in because it's as if the universe handed scientists the ultimate puzzle and said, "Good luck, you'll need it." Every measurement, from spectral lines to luminosity, contributes to understanding how the most massive stars influence galaxy formation, chemical enrichment, and even the origin of elements that eventually make planets and life possible. Its discovery also challenges our previous assumptions about what stars can be. For decades, astronomers thought stars above a certain mass couldn't exist. they'd collapse under their own weight or lose mass too quickly. Humor creeps in because it's like the universe waving at us and saying, "Watch this," then producing a star that breaks all the rules. Understanding this star means rewriting textbooks, recalculating models, and rethinking what is physically possible in the cosmos. And the more scientists study it, the more questions arise. How did it form without blowing apart? How stable is it really? What will its death look like, and could we detect it from Earth? Humor sneaks in because imagining the universe holding a star this big as if it were a cosmic pet, knowing it could go boom at any moment, is both terrifying and slightly absurd. Observing it teaches us humility. The cosmos operates on scales, energies, and timelines that dwarf human experience in every way. Finally, understanding this star forces us to reconsider the fragility of our own existence. On a galactic scale, we are tiny, insignificant, and almost comically vulnerable. Humor creeps in because while we fuss about Wi-Fi outages or traffic jams, this star casually burns billions of times more energy than our sun, sculpting the universe and reminding us that the cosmos does not care about human schedules. And yet, despite, or maybe because of its overwhelming power, it inspires awe, curiosity, and a profound appreciation for the sheer scale and drama of the universe. The most terrifying and fascinating part about a star this colossal is its inevitable demise. Stars of this size don't fade quietly into the night like our sun will. They end their lives with a spectacle that makes ordinary supernovas look like birthday candles. Humor sneaks in because it's almost like the universe decided that subtlety was overrated, and that if something this big exists, it might as well make a scene. When the star finally runs out of fuel, the core will collapse under its own weight, triggering a hypernova or even a parent stability supernova. The explosion will release more energy in a few seconds than our sun could produce in its entire lifetime. Nearby star systems, and anything in them, would be obliterated instantly, a cosmic reminder that scale matters. The death of this star could also give birth to one of the most massive black holes ever formed outside of the early universe. Humor creeps in because picturing a black hole forming from a star this size is like imagining a vacuum cleaner so powerful that it swallows your entire neighborhood, and then decides it wants the whole city. The gravitational pull would be immense, warping space-time around it, and creating effects so extreme that even light cannot escape. Scientists observe these processes not only to understand stellar evolution, but to glimpse the physics of matter and energy under conditions humans could never replicate on Earth. Yet, as terrifying as this star is, it's also a cosmic storyteller. Its life and death teach us about the life cycles of galaxies, the formation of elements, and the dynamic processes that shape the universe. Humor sneaks in because while it casually rips apart planets and ejects material at millions of kilometers per hour, we are here scribbling notes, taking spectra, and debating numbers with coffee-stained fingers. Every observation, every calculation, is like translating a dramatic epic written in light, gravity, and nuclear fusion. Its influence doesn't stop at destruction. The elements produced in its core, from carbon to iron and beyond, will seed surrounding space, providing the raw materials for new stars, planets, and potentially life. Humor creeps in because it's almost poetic in an absurd way. A star obliterates worlds, flings enriched matter across light years, and inadvertently contributes to the possibility that one day, somewhere, another civilization might stare at their sky and gasp. Its death becomes a paradoxical gift, a reminder that creation and destruction are two sides of the same cosmic coin. From a human perspective, the existence of such a star is both humbling and absurdly amusing. Humor sneaks in because while we stress about minor inconveniences, spilled coffee, lost keys, or traffic jams, the universe casually builds stars capable of reshaping entire galaxies and doesn't even bother to check if we're paying attention. And yet, our curiosity, observation, and analysis allow us to witness this drama from millions of light years away. We are tiny, but we are persistent. We are fragile, but we are bold enough to study something that could annihilate us in an instant if we were closer. Its discovery also stretches the imagination about what's possible in the universe. If such a star can exist, then the limits of physics, size, and energy are far broader than we assumed. Humor creeps in because it's as if the universe is giving scientists a wink and saying, "You thought you understood me? Hold my fusion." By studying it, astronomers learn not just about one extreme star, but about the processes that govern the birth, life, and death of stars on all scales, helping refine models that explain everything from galaxy formation to the abundance of elements essential for life. The star's violent life and death also invite reflection. Humor sneaks in because we small humans with our short lifespans are watching something evolve and explode on timescales that make our entire species seem like a fleeting thought. Yet, in understanding it, we connect with the vastness of the cosmos, gaining perspective, humility, and a renewed sense of wonder. Observing such extremes challenges our assumptions, stretches our comprehension, and reminds us that the universe is a place of endless surprises. And perhaps most thrilling is the reminder that stars like this are out there, quietly living their chaotic, brilliant lives, oblivious to our tiny existence. Humor creeps in because we obsess over the trivial while this star casually burns, ejects, and threatens from millions of light years away. Yet we are somehow fascinated, studying it with spreadsheets, telescopes, and equations. The sheer audacity of it, existence on a scale so extreme it dwarfs comprehension, is both terrifying and exhilarating. In the end, the biggest star ever found is a paradox, simultaneously destructive and creative, terrifying and enlightening, absurd and beautiful. Humor sneaks in one last time because it's absurdly human that we find joy, curiosity, and meaning in observing something that could obliterate us completely if circumstances were slightly different. Its existence reminds us of the drama inherent in the cosmos, the fragility of our place within it, and the endless potential for wonder that the universe holds. And as we continue to study it, each measurement, spectrum, and observation deepens our understanding, not just of this star, but of the universe itself. Humor creeps in because in the midst of all this, we're still standing on our tiny planet, marveling at a star hundreds of times bigger than the sun, making notes, sipping coffee, and laughing at the sheer audacity of it all. It's terrifying, it's inspiring, and it's exactly why we look up.